One of the most important practical issues that would enable the optimization of precast box culvert design is the exposure class that is specified for the culvert itself. The exposure class is the fundamental basis upon which the required cover to the reinforcement is used. The exposure class, an XC exposure class, for example, would require a lower concrete cover to the reinforcement than an XD exposure class would. Now, if you look at the box culvert itself, the sections generally are quite thin, 200 millimeters, 250, 300 millimeters. So a difference of 10, 15 millimeters in the cover to the reinforcement actually has a significant impact for box culverts, for the slabs and the walls of a box culvert. Now, at the moment, it seems standard practice to specify XD exposure classes for nearly all box culverts. And this is certainly appropriate in cases where you've got saline exposure or de-icing salts. But there is one situation at the moment wherein there is a requirement to waterproof the top slab of box culverts down into the side wall, and then as you can see, we've also got waterproofing applied down the side face as well too. But there is a very high quality waterproofing that is typically required for box culverts, the top slab and the top of the walls. Now, it can very justifiably argued, in fact, BS 8500 explicitly states that when a competent waterproofing layer is used, even though you have a road above the culvert and the presence of de-icing salts, that the argument can be made that an XC exposure class could be suitable. If this is done, and if this consideration is done, if an XC exposure class is used where appropriate as opposed to an XD exposure class, we can get away with less cover to our rebar, we have a greater effective depth of our reinforcement, and consequently we can potentially design a more structurally efficient and a more economical box culvert cross section. Another practical item that affects the design of box culverts as well is the use of high-grade, high-strength concrete. Now, the use of high-grade, high-strength concrete for box culverts generally will not make a huge difference with regard to the ultimate limit state bending check, which typically governs the required thickness in rebar. However, if your serviceability checks, and the Eurocode now requires stress limit checks to be carried out for serviceability conditions, if those stress limit checks fail, then there is huge benefit in specifying a high-grade concrete, which will typically enable those stress limit checks on the concrete to pass. That is another practical issue that has significant benefit to the design of box culvert. The third issue, and one that is causing us a lot of problems and has a huge impact on required reinforcement at the moment, is the overlap of wheels that are applied to the fill, applied to the surfacing above the top slab of the culvert. Now, all design codes allow you to disperse that wheel load through the fill down onto the top slab of the culvert. In the days of the British Standard, when we were using BD 31 as our fundamental basis for design of box culverts, whenever those dispersed wheel profiles overlapped, we were allowed to pick off that cumulative dispersed area and apply the cumulative wheel loads uniformly over that area. What PD 6694, which has now been brought in conjunction with the Eurocodes, requires us to do is whenever we have an overlap of those wheel loads, we essentially have to apply double the magnitude. We have to sum the magnitude of those dispersed wheel load profiles over that area. This actually can have a very significant impact and can dramatically increase the shear and bending moment that our culvert is required to carry, and subsequently the amount of reinforcement, the potential for shear links, and also the required thickness of the culvert can also increase as a result of that. So we would certainly encourage all consultants to consider and to apply for a departure from standard from PD 6694, essentially requesting that we go back to the old BD 31 way of examining overlap wheel loads. And the economic benefits of that and the structural accounting benefits of that are very significant.